Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video. And today's video is about another interesting topic in Unit 4. We're going to see execution of a complete instruction and how the branch instruction is getting executed. Okay. In previous video, we have seen just how the processor fetch a word from the memory and how it stores the word from the memory, right? Here, what we are going to do is we are going to see how the complete execution of the instruction is going to take place, okay? And this is very important question in this particular unit, okay? And before going to that, right, I am explaining this concept in almost in all videos because this is the very basic of information which we studied in Unit 2, correct? Right. So here what we are doing is in Unit 4, we are just seeing how the processor performs all those basic operations, right? So this particular execution of an instruction is very, very important, okay? So we have already seen this many times, but here once again I'll explain very shortly about this, right? If you want to understand in detail, just go to the second unit video of basic operational concept so that you can clearly understand this particular execution. Okay, right. So now, right, we know that whenever any particular instruction, right, that is, say for example, you have an instruction, move R1 to R2. This will be saved in the memory, right? Whenever the processor need to execute this particular instruction, right? Right, it performs two phases. One is fetch phase, another one is execute phase, correct? Execute phase, okay? Right? So, understand very clearly, I'm going to explain little in depth because we have some additional concepts here compared to the previous videos, okay? So first the processor has to get this particular instruction itself, okay, from the memory. So what it will do, it will send the address information of this particular instruction to MAR, correct? And from MAR, what it will do is it will get the information through MDR, correct? This particular instruction will move to MDR, and then from MDR it will move to IR, right? Instruction register, correct? And once the instruction reaches the instruction register, only here the processor will start decoding that particular instruction. Only here it will understand what is that information, whether we have to add, whether we have to move, only after reaching the IR, right? So, understand very clearly where the instruction starts, right? Where the instruction execution starts. It's not from MAR, right? That is, this instruction will be first, it will be in PC, program counter. Program counter is the one which has the information of the next instruction that is going to execute it, right? அடுத்து என்ன information execute ஆக போதோ அதை வச்சிருக்கிறது என்னது program counter, right? The program counter will have the instruction which is going to be executed next. And what is IR? IR is the one which holds the information of the current instruction that is executed, correct? And only from PC, whenever the PC has some instruction, the PC is the one which will have this instruction, move R1, R2, right? And only from here it reaches the MAR, and then it goes to MDR, and then it goes to IR, right? So as I said, that is something called the fetch phase, right? So fetch phase, I will explain many times. That is, the instruction starts from PC and reaches the IR. That is fetch phase, right? And after reaching the fetch phase only, the execution phase will start, correct? So execution phase will start, which means only after reaching the IR, the execution will start. That is, the instruction decoder will come into action, right? So this is the complete operation of a particular instruction, okay? Now you have to understand one point very clearly, right? The one point here is, now the PC, the content in the PC is sent to MAR and then MDR and then reaches the IR and the execution will start, correct? Right? As soon as the content from PC moves to MAR, what happens here? The PC will be incremented to the next instruction, right? So I said, if you have instructions like this, R1, R2, move R1, R2, right, like this. That is, the first instruction is add. First instruction is add and the second instruction is move, right? So first the program counter, it will start this particular instruction, right? Once the content of this particular instruction moves from program counter, the program counter will be incremented to the next instruction. That is, this is PC and this is PC plus 4, right? Only then the instruction will be executing in order, right? Because if it becomes empty, then no instruction will get executed, because PC is the one which will have the information about the next instruction that is getting executed. Okay, so in the fetch phase, this is not only that PC, the instruction reaches from PC to IR, it also performs another function, that is, parallelly it also increment the PC value to 4. Right? Clear? Right? You already know what is fetch phase, what is executed phase. Right? Here you have to understand fetch phase performs two operations. One is, it is nothing but the content of PC is moved to IR. That is one particular thing. Another thing is, parallelly PC will also be incremented to the next instruction. Correct. Why is that I'm stressing out here is the complete operation, you have to explain everything here. Clear so far? Okay. Now we'll see this particular example. Okay. How to execute a complete instruction. This is the instruction. Add R3, R1. Right. So what happens here? We have to add the content of R3 to R1. Right. There is some content. Right. There is some content in R3 and there is some content in R1. Right. So we have to add the content of R3 and R1 and we have to save the content in R1. Correct? We have to save the content result in R1. R3 plus R1. Right? It has to save it like this. Right? We can mention like this. We can mention like this. We have to add the content of R3 and R1 and place it in R1. Right? So, for executing this particular instruction, what I have to do? First, I have to fetch this instruction. Right? What is fetch the instruction? Fetch the instruction means the instruction must move from PC to IR. Correct? Right? Similarly, the content of PC must also be incremented. Right? And only then it goes to the next step, which is execution phase. Correct? So, this is the first step. It has to fetch the instruction. And once the instruction is fetched, what we have to do? We have to fetch the operand. That is, we have to fetch the data of R3. And then we have to fetch the data of R1. Right? And then we have to perform the addition. Using ALE, we have to perform the addition. Right? And then we have to save that in the R1. Correct? Right? I'm just explaining this particular instruction alone. Right? First, you have to fetch this instruction. And then what you have to do? You have to fetch this operand. And then you have to perform the addition. And the result has to be saved in R1. Correct? Right? And similarly, as I said, fetching the instruction means it has to perform two things. It has to move the content from PC to IR and it has to increment the PC to 4. Correct? Right. Now, I am just going to explain this in program. You can see here what I am going to do here. Right. So, listen very carefully. Right. As I said, what is the first one? The content of PC, the fetch phase, right? Fetch phase has two things. Right. What I said? Two things. PC to IR and then PC plus 4. Correct? Right. Now, the operation what starts with PC and then it should end with IR, the fetch phase, and also PC must be incremented to 4. Correct? Right? Now I will explain how this happens. Okay? Now you can see here, right? From PC, right? From PC out, it is sent to the MAR, right? MAR. That is what I have explained, right? From MAR only, it will go to the processor through MDR. Correct? Right? So you can see here the content of PC, the original content of PC, right? It is sent to the MAR and the read cycle is initiated. Listen very carefully. Read cycle is initiated, right? And at the end of the read cycle, right? Don't worry about all this instruction. Just concentrate only in the tick marks I have mentioned. Okay? Right? And it will initiate the read cycle, right? So what now processor will do? It will wait until it receives this particular signal, right? So it receives this particular signal, right? Once it reaches this particular signal, which means the read cycle is completed. So the content of MAR is saved in MDR, correct? Once the MDR receives the data, it will be sent to the IR, right? Right? Now the complete instruction, this particular instruction is reached the IR. This particular operation is done, right? One operation is completed, right? Correct? From PC, it is sent to MAR, right? And then it initiates the read cycle and it waits for the MFC signal, right? At the end of the read cycle, the content is stored in the MDR, and from MDR, the IR, it sends to the IR. So the fetch phase, the one operation of fetch phase is completed here. What is the other one? Parallelly, what it has to do? It has to increment to 4, right? How it can happen, right? So you can see here, right, the content of PC, right? I'll say the content of PC, it is sent to the MAR, right? And from MAR, what happens? From MAR, at the end of the read cycle, it is sent to the MDR, correct? Right? It is MDR. From MAR, the content, right, at the end of the read cycle, it reaches the MDR, and from MDR, it reaches the IR, correct? This is from PC to IR, completed, okay? Parallelly, what will happen is, the content of PC here, right, it is, the instruction is sent to the MAR here, right, is fetching the instruction, right? And similarly, here, parallelly, what will happen, the content of PC is sent to the internal bus, correct? Right, and this from internal bus, it will send to this particular input ALU. Listen very carefully, right? It is sent to the input B, right? You can see here for ALU, you have two inputs A and B, right? One is directly obtained from this particular internal bus, and other is obtained from constant 4 or Y, that is selected by multiplexer. Correct? And depending upon this control signal, right, the operation will be executed. Right? Now there is no other operation. Now the content of the PC, right, is reached the B. Now what will happen? The multiplexer will select this constant 4 and it is given to A. Select 4 is obtained and it is sent to the A. Now you can see the A will have constant 4 and B will have the value of PC, correct? The PC, right? Now what will happen here? Right? Now this PC plus this 4 will be added, right? So what will get? PC plus 4, right? This is the updated value of the PC, correct? So this particular ALU will add the PC plus 4 and that information is sent to the Z, correct? This is nothing but a temporary register. Right, from once again the temporary register, what will happen? From temporary register, it is sent to the internal bus, correct? It is sent to the internal bus, right? And from internal bus, once again, the content, what is the content you are sending here? It is sent to the PC plus 4. That is, we are getting a new value to the PC, right? So this PC4 will reach the PC. That is the next instruction that is going to be executed, which is the second operation of the fetch phase. Clear? Clear with that? Right. That is what I am going to explain here. Right. So now what will happen? Parallelly, right, it will reach, the content will reach the B. Right. The PC content will reach the B. Right. And the ALE will select 4 and addition will be done. Correct. And addition will be done and then it is sent to ZIN. Right. ZIN is nothing but this particular instruction. Right. This particular register. Right, and from this particular register, it is sent to Z out. It is sent to internal bus. You can see it is Z out, that is sent to internal bus, and it reaches the PC in. Right, and from PC, now this PC value is PC plus 4. This is PC plus 4. Correct. Right, and this PC plus 4, it will go to YN. That is for next instruction. That is this particular instruction. You can see here from PC, it can reach us to Y. That is for next one. Here. For this particular operation, this is not needed, but this is for generally from PC, it will go to the next one, the next instruction. Okay, clear? Right. So this is called fetching phase. Fetching phase. That is, two operations is completed. PC to IR is done. PC plus 4 is done. Right? So this is common for all the instruction. Whatever instruction which you are going to execute, you can able to write the same 3 lines for all the instruction, because this is nothing but the process. What is the process? From PC it is sent to MAR, from MAR it is sent to MDR, and from MDR, right, it reaches the IR. And similarly you are explaining another process how you get PC plus 4. This is the process. This is the common for all the execution, because the first step is fetching phase. This is the fetching phase. Okay. Now at the end of the fetching phase, what will happen? You can see here IR in. That is IR now will have this particular instruction, add R3 and R1. Now this particular instruction will reach the instruction register. Only now the instruction will be decoded. Right, the processor will decode this particular instruction. Now after decoding, now it will understand, right, we need an ALU and we need a content of R3 and we need a content of R1, correct? So that we have to add, right? So now what will happen? You can see here, once again it has to fetch the data, right? That is, first phase is it got fetch the instruction. Now it is going to fetch the data. You can see here R3 out, right? That is, the content of the R3 has to be added with the content of R1, right? That is right. So the content of R3 must be sent out to the internal bus, correct? So R3 out, and from there it reaches the MAR in, right? MAR in, and it initiates the read cycle. Why it initiates the read cycle? Because the content has to move to the MDR, right? Only then the processor will get that particular content. Right, so that you can able to add, right? So it initiates the MAR and it initiates the read cycle. Meanwhile, right, R1 out, there is another instruction that can reach sent to the Y in. Listen very carefully. We have initiated R3 MAR in operation, read cycle is initiated. Okay. Parallelly, what we have done, R1 is sent to Y in. Right. Parallelly, R1 is sent to Y in. You can see here. R1 content is sent to Y in, that is R1. For example, if this is R1, consider this is R1. This content will reach the Y in, right? If it reaches Y in, what will happen? It will, this multiplexer will select Y and it will reaches the A, right? It will reaches the A, correct? Right. So you can see here R1 the content, it will send to Y in, right? And it is still waiting for this read operation to complete. Once this particular signal is received, what will happen? The content of R3 will be saved in MDR, right? Because that is the read operation, right? So at the end of the read operation, now the MDR will have the content of R3, right? And now the content of R3 will be in MDR, right? Now you understand already one particular input reached the A, right? The content of R1 is reached the A. Right, now R3 is in MDR, correct? So now it sends to the internal bus and it is sent to the B. Right, you can see here it is sent to the B. That is not represented here, but from MDR it reaches the B. Okay, and it will always select the A, because select the Y, because in Y we have already what we have already R1. We have already R1. And B has R3, right? From Y, it is given as an input to A. Now A has the content of R1 and B has the content of R3, and add is initiated, right? Add control signal is initiated, and once it performs the addition, it is sent to Z in, right? And once it is performed Z in, it is sent to Z out. Through Z out, it is sent to internal bus, and from internal bus, what do you have to do? The content, the result has to store in R1, correct? So that is what going to happen. You can see here Z in, and from Z out it is sent to R in. That is, we have to add both the thing and we have to place the result in R1, right? So from Z out it is sent to the internal bus, and then from internal bus it reaches the R1. Clear? Step by step instruction. Okay. So you have to be very careful in the logic. If you understand the logic, you can write by yourself. Okay. You have to understand what is MAR, what is read cycle, what is MFC signal, and this is common for all the particular instruction. So this is the steps involved in executing a complete instruction. Okay, right.